All right, let's take a look at this question. Find the number of prime factors of 2 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 and up to 2 raised to power 16. To evaluate or to simplify this to get the prime factors of that, what we have is to look at the common factor here. What is the common factor? The common factor here is 2. Taking the common factor out, we're going to have 2 into bracket 1 plus 2 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 and up to 2 raised to power 15. Meaning, if you divide this 2 by this, you're going to have 1. Divide 2 raised to power 2 by 2, you're going to have 2. And if you keep dividing 2 raised to power 16 by 2, you're going to have 2 raised to power 15. So this 2 is common here. So from here now, I can decide to group these. What do I mean? 1 plus 2 as 1, group it together, group this, and also group this. Okay, so doing this now, I can find the common factor between 1 and 2 here, 2 raised to power 2 and 2 raised to power 3, up to 2 raised to power 14 and 2 raised to power 15. Okay, finding the common factor will lead to this. This is 2 into bracket. What is common here? We have 1. 1 is common into bracket 1 plus 2. If you open this bracket with 1, you're going to get this back. Coming over here, 2 raised to power 2 is a common factor. 2 raised to power 2, when you factorize this, getting the common factor, you have 1 plus 2. 2 raised to power 2 times 1 will give you 2 raised to power 2. 2 raised to power 2 times 2 here will give you 2 raised to power 3. And we have it up to 2 raised to power 14 into bracket 1 plus 2. And again, looking at the common factor, what is the common factor here? Look at it. 1 plus 2 is common here. 1 plus 2, 1 plus 2, 1 plus 2 here, 1 plus 2 here. Meaning 3 is a common factor here. So we're going to bring the 3 out of the bracket. Inside the bracket, we take it out and we multiply it with the 2 we have outside the bracket. That's going to give us this. We have 2 times 3. So if we have 2 times 3, we are left with this one. This is the one. Left with 2 raised to power 2, 2 raised to power 4, 2 raised to power 6, 2 raised to power 8, 2 raised to power 10, 2 raised to power 12, and up to 2 raised to power 14. Okay. Then the next thing, or the next stage now is also to group it just like we did in the first, in the last line. Group it together, this and this together, this and this together, and this and this together. And also when you're done with that, so find a common factor. What is common between 1 plus 2 raised to power 2? The common factor there is going to be this. 2 times 3, 1 is common. Bring the 1 out. That means 1 plus 2 raised to power 2 plus. Between these two, 2 raised to power 4 plus 2 raised to power 6. 2 raised to power 4 is common. And we're left with 1 plus 2 raised to power 2. If you multiply this 2 raised to power 4 times 1, that's going to give you 2 raised to power 4. 2 raised to power 4 times 2 raised to power 2 will give you 2 raised to power 6. Then the next thing between 2 raised to power 8 plus 2 and then 2 raised to power 10. So we're going to have 2 raised to power 8 as a common factor, where we have 1 plus 2 raised to power 2 in the bracket, and which is also the last one here. The common factor is 2 raised to power 12 into bracket 1 plus 2 raised to power 2. So also something is common here, and what's that? We have 1 plus 2 raised to power 2 as the common factor. 1 plus 2 raised to power 2 as a common factor. And when you take a look at that, 1 plus 2 raised to power 2 will give us what? 5. 2 raised to power 2 is 4 plus 1, 5. So 5 is common here. We bring the 5 out of inside the bracket to multiply it with 2 and 3 that we have outside the bracket. And that's going to be 2 times 3 times 5. So we are left with this one, 2 raised to power 4 here, 2 raised to power 8 here, and 2 raised to power 12 here. Okay, we have 2 times 3 times 5. Don't forget, the question says find the number of prime factors. 2 is a prime factor, 3 is a prime factor, and 5 is also one of the prime factors that we are looking for. So we have 3 now, but we are not done yet. We still need to continue to get other prime factors. We are left with these 2 times 3 times 5 into bracket 1 plus 2 raised to power 4 plus 2 raised to power 8 plus 2 raised to power 12. Let's take a look at these 2 as well to find a common factor between 1 and 2 raised to power 4. That means 1 plus 4, there should be a common factor there. 2 raised to power 8 plus 2 raised to power 12, there should be a common factor there. And that's the common factor between these 2 is 1. We still have 1 plus 2 raised to power 4. Then the common factor between these two is 2 raised to power 8, where we have 1 plus 2 raised to power 4. Again, 1 plus 2 raised to power 4 is common here. Then, if we have 1 plus 2 raised to power 4 as a common factor, what is now the result of 1 plus 2 raised to power 4? That means 2 in 4 places. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 plus 1, that will give us what? 17. So 17 is common here. We bring the 17 out of the bracket, and then inside the bracket, we multiply with the numbers we have outside the bracket, and we take it up from there as well. Meaning 2 times 3 times 5 times 17 into bracket, we are left with this 1 and 2 raised to power 8. So 1 plus 2 raised to power 8, meaning that we have 2 times 3 times 5 times 17 times 1 plus 2 raised to power 8. So let's try and find the value of 1 plus 2 raised to power 8. 1 plus 2 raised to power 8 will give us what? 2 raised to power 8 is 256 plus 1, that will give us 257. So in a nutshell, we have 2 times 3 times 5 times 17 times 257. So this is just the prime factorization of the numbers that we have at the top here, 2 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 up to 2 raised to power 16. And the question is saying we should find the number of prime factors. Counting this now, we have 1, 2, 3, 4, 5. So 5 is the number of prime factors that we have in this question. We can also take a look at this question from another angle, okay? Taking a look at it from here. Just hold on, let me clean this. Okay, we can also use geometric progression. We all know our geometric progression very well. So from this, let's take a look at how we can use our geometric progression to also work this out. This is the formula of a hand time, okay? We have AR raised to power n minus 1 is equal to UN. From what we have here, the UN is going to be 2 raised to power 16, which is the last number here. And then when you take a look at it, our A is the first term, which is the 2 here, okay? The R we have there is the common ratio. How do you determine your common ratio? Of course, this is 2, this is 4, because 2 raised to power 4, 2 raised to power 2 is 4. 2 raised to power 3 is 8. So by getting your common ratio, you have second term divided by first term, or third term divided by second term. So if you have this as 4, we divide it by 2, we're going to get 2 as our common ratio. If you have this as 8 divided by 4, you get 2 as your common ratio. So our common ratio is 2. Then our n here, we have n minus 1. Our n is also 16 from what we have here. Okay, sorry, we want to look for the number of terms first. Here we have 2 plus 2 raised to power 2 plus 2 raised to power 3 plus 2 raised to power 4 and up to 2 raised to power 16. Like I've said, some numbers are missing in between. So with this, we cannot calculate or we can't know the number of terms that we have in the series. So all we need to do is to get the number of terms first. And getting the number of terms, here we have, by splitting this, we have 2 raised to power 1 times 2 raised to power n minus 1. Okay, which is equals to 2 raised to power 16. Now, using the law of indices to solve this, and when you have the same base, okay, you have to work the power out. This becomes 2 raised to power, meaning 2 raised to power n is equal to 2 raised to power 16. This one is positive, this one is negative. So this one, we go with this one, you are left with n. So we have 2 raised to power n is equal to 2 raised to power 16. So with this, we can cancel out the base, okay? This can go with this. Then we are left with what? N is equal to what? Is equal to 16. So if our n is equal to 16, so 16 is telling us that, n is telling us that the number of series that we have here is 16. If that is the case for n, then let's take a look at the sum. We want to look at when we sum these numbers together, what is going to be the total sum. So we're going to use a formula for sum of a geometric progression, okay? Sum of GP. Sum of GP is equal to Sn is equal to A into bracket R raised to power n minus 1 over R minus 1. From here, we're going to find this value of A, R raised to power n minus 1, we'll fix it in. Okay, A, like I said, is the first term, which is 2. And common ratio is also 2. And we said our n is what is 16. So we substitute those values in. Oh, we have now 2 into bracket 2 raised to power 16 minus 1. and this is 2 minus 1. From here, 2 raised to the power 16 minus 1, what will be the value of that? That's, of course, 2 minus 1 will give us 1, so we don't have any problem with the denominator any longer. So here, 2 raised to the power 16 will give us 65536, that's 65,536 minus 1. So when you subtract 1 from it, you're going to get 65535. Multiply it by 2, your final answer is going to be 131070. That's 131,070. So from here, we need to get our prime factorization for this. And how do we get our prime factorization? We divide this number by 2. 2 in this number, that will give us 65535, meaning we can use 3 to divide this number. How do we know that 3 can go? Use your rule of divisibility, your divisibility rule. Okay, 5 plus 3, that's 8. 8 plus 5, that's 13. 13 plus 5, that's 18. 18 plus 6, that's 24. So 3 can go in 24. So 3 can go in this number. That means we have 21845, 21,845. So 5 can as well go because the last digit here is 5. So 5 in this number, that will give us 4369. Okay, then 17 can go in this number, and that is going to give us 257. So 257 as well can go in 257, and that will give us 1. So when you take a look at this number, we have 2 times 3 times 5 times 17 times 257. So the number of prime factors is also 5. So you can use the first method or use the second method. So this is the end of today's class. If you like this video, please subscribe to the button below, share, comment, and also like the video. Thank you.